Hello students, in this video we are going to learn about the realization of 2:1 multiplexer. In our previous video, we have seen about the various CMOS design styles and certain problems related to the MOS style. Now we are going into the second module, which is all about multiplexer, encoder, decoder, and certain other combinational circuits. Now we will see one by one. So here we are going to realize 2:1 multiplexer using pass transistor logic and transmission gate logic, right? So now, what is pass transistor? The transistor is going to pass something. When it will pass? Only when my control signal is equal to 1, because my pass transistor is an NMOS transistor. So if my C is equal to 1, if my C is given equal to 1, my N MOSFET will turn on and whatever value is there in A will be passed to the B, and thereby B is equal to A. If suppose my control signal, which is C, is equal to 0, then my B is equal to 0, which means if my control signal is not given, my B data will be 0. Now, using this pass transistor, I am going to implement 2:1 multiplexer. So, what is a multiplexer? Many to one will blindly say, but what actually it is? Many data will be there, and there will be certain select lines. Using those select lines, we will be selecting the data, and that particular data will be at the output. Now, 2:1. 1 is nothing but your output. Then what is this 2? 2 is your input. So I said that with the help of select line, we are going to select. So how many select lines will be there? If there are 2 power k inputs, k number of select lines must be there. Now what is 2 power 1? 2 power 1 is equal to 2. So 1 is the select line. So now see, A and B are the two inputs, and there is one select line, and my Y is the output. If suppose my select line is equal to 0, if I am feeding 0 as a select line input, what has to be selected? See, if S is equal to 0, whatever value is there towards A will be at the output. And if my select line is equal to 1, what is there in 1? B. So my output Y is equal to B, right? So if select is 0, what is there towards 0? A. So my output will be A. If my select line is 1, what is there towards 1? B. So Y is equal to B. So what is the output expression I can write? Output expression, Y is nothing but A into S bar plus B into S. Now, what is the truth table that I have written? S and Y. What is S? S is the select line and Y is the output. So if select line is 0, Y is equal to A, and if select line is 1, Y is equal to B. So with this, we can write an expression. That expression and those previous expression is the same. So Y is equal to A into S bar. As S is equal to 0, I can write S bar plus B into S. This is the multiplexer, 2:1 multiplexer's Boolean expression. Now, with this expression, I am going to realize the multiplexer using pass transistor, right? Now see, Y is equal to A S bar plus BS using pass transistor. So now, Y is equal to A S bar. My control signal I am giving as S bar. The first top transistor I am giving S bar as the control signal. What is this? It is nothing but AND operation. So Y is equal to A into S bar will be at the output. That is ORed with B and S. So B is one input and S is another input. So B into S plus A into S bar. That will give you the pass transistor version of multiplexer. So how the expression will be, or how the working will be? See, suppose I am giving S is equal to 0. What must be at the output? A must be at the output. How can I say this diagram is going to implement the multiplexer? See carefully, when S is equal to 0, 0 to an NMOS will switch off. So bottom NMOS will turn off and the top NMOS will turn on as S bar is equal to 1. So when the top transistor is turned on, what is there in the top transistor? A. So the output will be A. If my S is equal to 1, what is going to happen? S is equal to 1, S bar is equal to 0. So the top NMOS is going to turn off, because 0 to an NMOS will turn off it. And then the bottom transistor will turn on. So top is off and bottom is on. What is there in the bottom side? B value. So Y is equal to B. Now we are going to implement the same 2:1 multiplexer expression. What is that expression? Y is equal to AS bar plus BS using transmission gate. So what is a transmission gate? Transmission gate is a parallel NMOS and a PMOS. Right? It is a parallel PMOS FET and an NMOS FET. Both are connected in parallel. It is not a new thing. Both top is a PMOS and bottom is an NMOS. And together it is provided with a control signal. Control signal, if it is S0, it is S0 bar. Right? It is a negated operation. This transmission gate can also be drawn in this format also. M is the input, Y is the output. If suppose my S0 is equal to 0, if I give S0 is equal to 0, what is S0 bar? S0 bar is obviously 1. So what will be at the output? See, S0 is equal to 0. 0 will turn on your PMOS and S0 bar is equal to 1. 1 will again turn on your NMOS. So what is that? Whatever value in M will be passed at the output Y. So Y is equal to M. If suppose my S0 is equal to 1, if S0 is equal to 1, S0 bar is equal to 0. So S0, when it is given as 1, 1 will turn off your PMOS and S0 bar is equal to 0. 0 will turn off your NMOS. So it will be in an off state. So the value of Y will be in the high impedance state. It's not predictable. Now, using this transmission gate, I'm going to implement a multiplexer, 2:1 multiplexer. We'll see how we can implement it. See, Y is equal to AS bar plus BS. I'm having two transmission gates. The top transmission gate is provided with the control signal S and S bar, and the bottom transistor is given with S bar and S. And I'm having two datas A and B onto my left, and to the right I have Y, which is the output, and I have written Y is equal to AS bar plus BS. Now we'll see how it is working. When I'm giving my S is equal to 0, what is S bar? S bar is equal to 1. So if 0 is given to the top transmission gate, the upper transmission gate will turn on or off. 0 to a PMOS will turn on it. S bar, which is 1, 1 to an NMOS will turn on it. So the upper transmission gate is going to turn on, whereas S bar is equal to 1. 1 is going to turn off your PMOS and S is equal to 0. So this 0 is going to turn off your NMOS. So what is going to happen? The bottom transmission gate is in an off state, whereas the top transmission gate is in an on state, right? So that will transmit what data? Y is equal to A. Now, S is equal to 1. We shall see for the other combination as well. So when S is equal to 1, what is S bar? S bar is also equal to 0. Now, 1 to a, what is this? 1 to a PMOS will turn off the upper transmission gate, and S is equal to 1, that is given to an NMOS. This will turn on this bottom transmission gate. So what data is there? B is there, and B will directly pass at the output. So Y is equal to AS bar plus BS. My multiplexer using transmission gate is be implemented. So in next video, we shall see about the realization of 4:1 multiplexer. Thank you.